Here's the master exam review key for standard 3. All right, let's get into it. So I'm going to describe the following three situations as either linear, quadratic, or exponential. So we're looking for specific things when we're looking at these expressions. Okay, so in the first one, we have x, 2x. Let's change the color too. We have 2x times 3x, which will give us 6x squared. Because it's squared, okay, that's going to be a quadratic. Okay, and the reason being is largest exponent is 2. All right, for the next one, b, we don't have anything to multiply, but the exponent on this x is a 1. Because it's not written, it is a 1. That means this is a linear function. All right, and the reason being is that the largest exponent is a 1. Okay, and lastly, part C, the exponent is x, which means it must be exponential. And the reason being is the exponent is x. All right, and that is why those three things are named the way they are. All right, next, write a quadratic function given the vertex and that point, okay? So we're given enough information to write the equation. So this is what we're going to do. We're going to first identify our vertex, which is h comma k. That is 8 and 12. All right, this other point is going to be x and y. So all we have to do is put these values into our format for a vertex equation, a quadratic vertex equation, which looks like this. Y is equal to a times x minus h quantity squared plus k. So we're going to put the h, k, x, and y into our equation here, but we have to solve for the a, which is the part we don't know. Once we find that a, we can rewrite the equation with the a in the equation, but we don't need to put the x and y values in there. All right, so this is what it looks like. Y is 4, a we don't know, x is 6, minus h, which is 8, quantity squared, plus k, which is 12. So we put all the values in where they belong in our formula. All right, and now we start solving. So we're going to subtract 12 from both sides, which gives us negative 8 equals a. And then 6 minus 8 is negative 2, and negative 2 squared is 4. We're going to divide by 4 on both sides, which a is going to then be negative 2. Now we solve for a, but we're not done. We got to rewrite the equation. We're going to rewrite the equation with the a value involved. We don't need to put the y and x values, though, in the equation. So we got y is equal to negative 2 times x minus 8, quantity squared, plus 12. And that is your answer. Number 3, same idea. All right, so this time you're not given the vertex explicitly, but you're told that you have it. All right, because you're told that this is the maximum point. All right, the maximum is a vertex for a quadratic equation that is pointing downwards. Okay, so this is the vertex at negative 3 comma negative 2. So this is h comma k, and your point here is x comma y. So we're going to do the same thing we just did. So we're going to have y is negative 6 equals a times x, which is negative 2, minus h, which is negative 3. Notice I put it in parentheses as I did that, squared, minus 2 for k. Okay, so I'm going to add 2 to both sides. So I get negative 4 is equal to a. All right, negative 2 minus negative 3 is going to be positive 1, and 1 squared is 1. Divide both sides by 1 if we really need to. A will equal negative 4. Now we rewrite the equation. Y is equal to negative 4 times x. A minus is going to be plus 3. Quantity squared minus 2. Some might be asking, why did we do a minus minus? Well, the formula for a quadratic equation is over here that I wrote at the first problem we did. You notice it says minus h, so that means that minus is part of the formula for the equation. So it's got to stay there. So when you put an h value in, it changes signs. So it is negative 3 in this problem, becomes positive 3 inside the parentheses, because I had to change signs because the formula had a minus sign to begin with. All right, number 4, same idea. We have h, oops, forgot to change the bounds. H and k, x and y. So we start off with 6 is equal to a times 3 minus 5, quantity squared, minus 6. Okay, so we're going to add 6 to both sides. Gives you 12 is equal to a. 3 minus 5 is negative 2, and negative 2 squared is 4. Divide by 4, and a will equal 3. All right, so now we're going to rewrite the equation. Y is equal to 3, x minus 5, quantity squared, minus 6. There you go. Again, we're not told it's a vertex, but we are told it's a maximum, and the maximum point is the vertex of the equation, of the graph, sorry. This is h and k. It'd be the same thing if it's at a minimum. If it's at a minimum point of a quadratic function, that would also be the vertex. This is x and y. So y is 2 equals a times 4 minus h, which is 2, quantity squared, and plus k is 0. Well, we don't need to add 0 or subtract 0 to the other side. It doesn't make any difference. So we have 2 is equal to a. 4 minus 2 is 2. 2 squared is 4. Divide both sides by 4, and a will equal 1/2. So we rewrite our equation. Y is equal to 1/2 x minus 2, quantity squared. We don't have to put the plus 0 because it doesn't make any difference. And that is the equation of our quadratic function. Okay. Here, these are the same problems we did in Power Standard 1 for the review, but I'll do them here. All right. In Power Standard 1, you had to draw the picture. I didn't really have to solve the equation for Power Standard 1, but for this problem and this Power Standard, you got to actually solve the equation, so it's going to be helpful to draw the picture anyways. So we have a firework projected vertically into the air from the ground, which means it's on the ground. So we'll draw a little picture for our firework. There we go. All right, it's going to go up in the air, and it's at the highest point. It's going to be highest point is going to be 50 meters. I'll get it. This is 50 meters, and horizontally it traveled 15 meters. So this is 15 comma 50. Okay. It says it lands 30 meters from the launch site. So this is going to be 30 comma 0. Okay. We're going to actually adjust this to make this a little bit smaller. There we go. Sorry about that. We're going to run out of space for our equation. So what that means is this is h comma k, this is x comma y. And the problem from Standard 1, that 30 meters from where it lands is not included, so we're going to change it up for this one. So they might be different types of problems. All right, so anyway, we have y is 0. We have a, we don't know. We have x, which is 30, minus 15, quantity squared, plus 50. So these are the same type of problems we just did in, what questions were they? 2 through 5. Where you given information, you got to find the equation. So we're going to subtract 50 from both sides. Negative 50 is equal to a times 15 squared, which is 225. So we have negative 50 divided by 225. So a will equal negative 10 over 51. Oops. Oh, sorry, I did that wrong. 50 divided by 225. I put 255. Something seemed wrong with that. 2 over 9. Where's my eraser? There we go. negative 2 over 9. Sorry about that. So we got y is equal to negative 2 over 9 times x minus 15, quantity squared, plus 50. So that is the equation for the parabola of the rocket launcher. All right. Here again we have a goalie punting the ball. So here's our goalie punting the ball. The ball is punted 2 feet above the ground. So this is 2, which means the ball is at 0, 2 when it's punted. It's going to go up in the air. Its maximum height is going to be 50 feet. It's going to be 20 feet from the player's foot. So this point will be 20, 50. Okay, so this is the x and the y. This is the h and the k. So the y is 2 equals a times x, which is 0, minus 20 squared, plus 50. We're going to subtract 50 from both sides to give you negative 48. Equals a times 400. And negative 48 divided by 400 a will equal negative 3 over 25. Rewrite our equation. Y is equal to negative 3 over 25 times x minus 20, quantity squared, plus 50. And that is the equation of our ball being kicked. All right. So you'll notice that 2 through 7, basically the same kind of thing. You're finding the equation given x, y, h, and k. Okay, it's just that 6 and 7 are word problems, and you're not given word problems for the other 4. Okay, next, using the fundamental theorem of algebra, explain why the graph below can be represented by the equation. Okay, and the reason why is when you're looking at this type of problem, you need to find as many roots in the equation as there are, degrees in the equation, as there are roots in the graph. So because we have 3 x's, we're going to get x to the third. That means we can have 3 roots in our graph, which we do. So this y, and why it's yes, is because the roots of the graph are the same as the degrees of the equation. Okay. Here we got to say why it cannot be. Well, in this case, we have 2 x's, okay, which means our degree is going to be x squared when it's all said and done. But if you look at your graph, it crosses the x-axis at 3 different spots. Well, that can't happen, okay? So, this is a no, because there are more roots in the graph than there are degrees. Did I spell that right? In the equation. I didn't. There we go. All right, so you can't have more roots in your graph than you have degrees in your equation. Okay. Next, we're going to analyze these 2 functions. All right, we want to know which one has a greater number of real zeros counting multiplicity. Okay, so counting multiplicity means we have the number of zeros. So this has 2 zeros because there's 2 different factors, but one has a multiplicity of 3, one has a multiplicity of 2. So that means there's a grand total of x to the 5th. Okay, so what that means is that we want to look at the other equation and figure out how many roots it has. It has 1, 2, 3, 4. Okay, So if this one has x to the 5th, counting multiplicity, it's going to have more real roots than the graph does. Although the other one has 4, this one has 5 because it's counting multiplicity. If you weren't counting multiplicity, you only have 2, but you're counting multiplicity, so you're going to have 5. Okay. Next, analyze the function which polynomial has a greater number of extrema. Okay, so look at our graph. The number of extrema is the peaks and the valleys. This has 1 valley and 1 peak. They're small, but they're there, so it has 2 extrema. All right, this is a quartic function, which is x to the 4th. All right, the a value is less than 0, so it's negative. Has 1 double root and 2 other distinct real roots. That means the double root, what this means is the graph will bounce off the x-axis, and the 2 distinct other real roots means it will go through the x-axis. So let's show you how this works. So it's a quartic, so it's x to the 4th, and because it's negative, it's going to start at the bottom. Let's go through the 2 real roots first, or 2 other distinct roots. That's 1, 2, and then here's the bounce. It's going to bounce off the x-axis. That's the double root. All right, so let's count the extrema. There's 1, 2, 3 extrema. Well, 3 is bigger than 2, so this is the side that is got more. Okay. The rate of change between day 8 and day 12. So if we look at day 8 on our graph, it's going to be here. So this point is 8, 100. And day 12 is already given to you. So now to find the average rate of change, you're going to use the slope formula. So you have y2 minus y1 over x2 minus x1. For our y2, we're going to use 192 minus 100. So that means x2 has to be 12 minus 8. All right, which gives us 92.4 over 4. And we'll reduce 92 over 4, or 92.4. I'll get it. 92.4 divided by 4 gives us 23.1. All right, same thing here. I want to make this a little bit easier than I did for unit 1, or partial standard 1. We're just going to say it's 0, 10,000. That's your point here. And at 5, it's going to be 5, 0. So those are the 2 points we're going to use because it has to do between the points between the months 0 and 5. So our y2, I'm going to use the 0 minus 10,000 over 5 minus 0. So I'm going to have 10,000 over 5 is equal to 2,000. There you go. Same idea as the last one, using the slope formula to find the average rate of change. All right, here, we're going to do the average rate of change again, but this time comparing 2 polynomials. Okay, this part here tells us what x values we're going to use. It's not a point there. That is the range of values we're going to use, just like we did in the problems above. All right, you could have written the 8, 12 is, or 8 days 8 to 12 is like this, and the 0 to 5 like this. Okay, so the same thing we're going to use for -1 to 2. That means we're going to use -1, this point, and +2, this point. These are the 2 points we're going to use to find our average rate of change. All right, you're again using the slope formula, so y2 is going to be 11 minus 2 over 2 minus -1, which gives us 9 over 3 for a grand total of 3. That's your average rate of change for the points in the table. Now for the other part, it's a little bit more complicated because you're not given a table, you're not even given points. Well, what you can do is you can put the values that were given for the interval, -1 and 2, into the equation to find the points. So we're going to write them down. So we have 3, it's -1, right? Yep. So -1, and then -1 cubed minus -1 squared plus 2. All right, notice I put all the -1s in parentheses themselves to organize the information better. It's really important to do this because when you're squaring negative numbers, it causes you to have problems if you don't put them in parentheses. So this gives you negative 3, and then inside you have negative 1 minus 1 plus 2, which gives you 2, which gives you negative 6. So our first point is negative 1 comma negative 6. All right, now we're going to do the same thing with, what's the other part of the point? It is 2. So we're going to put 2 in for the x's. 2, so we have 2 cubed minus 2 squared plus 2. All right, so 2 cubed minus 2 squared plus 2 is 6. And then 3 times 2 is also 6, which gives you 36. Sorry, I said 12. So the other problem is 2 comma 36. So that's your other point. Now we have the 2 points. We can use those to find our average rate of change. So I'm going to put 36 as our y2 minus negative 6 over 2 minus negative 1. All right, which gives me 42 divided by 3. 42 divided by 3 is 14. Okay, so which one is a greater average rate of change? Well, 14 over 1 is a lot steeper as an interval or as a slope than 3 over 1 is. So this one's the better one. All right, last question here. Joey is making a patio with gray and white bricks. Patio has a total width of 6x, which you can see on the bottom there. All right. And a height of 3x, where x is in feet. 1 foot of rectangular space will be used as white bricks as shown. Okay. So the patio is represented by the function 3x times 6x minus. So we want to figure out the width of the shaded space. We're taking out 1 foot of these white bricks or white spaces. So we got to figure out first so how many there are. There are 1, 2, 3, 4. There are 4 bricks there that are 1 foot apiece. So we are subtracting 4 from the 6x part. From the total width, we're taking 4 feet away. Okay. So it says, what is the area of the total patio if the width of the shaded space is 20 feet? So if the width, this is representing, let's highlight this. Sorry, that's too much stuff. This is representing the width of the shaded space. So we have 6x minus 4, and it says the width of the shaded space is equal to 20. So that's our equation to start with. We're going to add 4, gives us 24, equals 6x, and divide both sides by 6. Okay, which equals 4. But we want to find out the area. It says, what is the area of the total patio? So we're going to put that 4 back in for the x in our equation. So we have 3 times 4 times 6 times 4 minus 4. Okay, so this will be 12 times 20. And 12 times 20 is 240 square feet. Actually, you know what? Let's do this. Feet squared. All right. That is it. That is standard 3. Good luck on the master exam.